All right, now number 17, you see a graph. I copied sort of a hand-drawn version of that graph right here. And let's answer these 5 or 6 questions here. The first question under number 17 asks what the limit is of fx as x approaches -3. Now notice here, this is a very important question, by the way. As x approaches -3 from the left or from the right, the value of the function goes to 1. Right at -3, the value of the function is actually 3, but that is irrelevant when you consider the limit of the function at x is equal to -3. Remember, we don't care what happens to the function when x is exactly -3. All we care about is what happens to the y as x gets closer and closer to, but never reaches -3. And the answer is that it goes down to this value here. Okay, so the limit is actually 1, even though the whole is there. Okay, and the value of the function at -3 is not 1, but that's again irrelevant. All right, number 2, what is the limit as x approaches 0? Well, if x approaches 0 from the right-hand side, this goes -infinity. From the left-hand side, it's +infinity. So this does not exist. What we have is basically the infinite discontinuity. As x approaches 2 from the positive side, the y value is getting closer and closer to 1. So the right-hand limit of f at as x approaches 2 from the right-hand side is actually 1. From the left, it's actually 0. Okay, but that's not in the question. What is f of 0? Well, f of 0 is indicated by this circle here. Okay, just one dot. So that is clearly equal to 2. The limit of f as x approaches 5. So you have x, let's let x approach 5 from the right and from the left. And in both directions, from both directions, the y value of 3 is what the function is approaching. So this will be 3. And in fact, it's continuous because it is also the value of the function. The last question says, in number 6, what type of discontinuity occurs at x is equal to 2? And you see what's happening when x is equal to 2 here. You have a hole, and this is the point where 2, 0 is actually in there, right? But that's discontinuous because of the jump. And therefore, we call this the jump discontinuity. Okay, let's go to number 18 next. Number 18 is to solve a logarithmic equation. Now, this logarithmic equation has a sum of 2 logs, and it's very important for you to know that the sum of 2 logs is not the log of the 2 sums, the log of the sums, but it's a log of the products of the the log of the product of the 2 arguments, x times x minus 1 in this case. Okay, so when you multiply this, of course, what you get is x squared minus x. Okay, and so now we have to translate this statement, a sentence written in the language of logarithm with base 6. What does this say? Well, that says x squared minus x, the argument is 6 to the first power, which is 6, right? Okay, so now we get to solve this quadratic equation. I think we can factor this into 2 and 3. You need negative x as the middle term. So this should be minus, this should be plus. X is -2 or 3. Don't think you are done, okay? Because sometimes when you go from here to here in this step, when you change the logarithmic sentences to an algebraic sentences, you may introduce extraneous solutions. Here, x is -2 or 3, but if you try to plug in a -2 in this situation or in here, log of -2 is not defined because the argument of every logarithm has to be positive. So we have to cross this out, okay? 3 would work because log of 3 plus log of 2 will be log of 3 times 2, which is log of 6. Base 6 is equal to 1. All right, so the answer is only 3. That's it, not -2 and 3. All right, let's go to negative. Let's go to number. All right, number 19 has 2 trigonometric equations. When you try to solve trigonometric equations, it's very important for you to know that in general, you do not use inverse tangent, inverse sine, inverse cosine functions. Keep that in mind, okay? Now you have 2 times something's equal to 2. Divide both sides by 2, and you get 1, right? Tangent square is equal to 1. That means tangent has to be plus or minus 1. Okay, now remember, both of these have to be there. Now, where is tangent plus or minus 1? On the unit circle, it's either here, here. Those are the places where the tangent is 1. Here and here, the tangent is -1, right? So the tangent of theta to be equal to +1 or -1, it's any of these places that happen every 90 degrees. All right, so the first one is pi over 4, okay? And then plus, let's just say this is going to be 1/2 k pi, because that k is any integer. And this is going to give us all this pi over 4 plus 90 times k pi, or 90 degrees times k, which is every 90 degrees. And because k is any integer, it can be negative, so it can go backwards. And so it's going to hit every one of these things. So the answer is pi over 4 plus k pi over 2. Second one, 1 minus sine of theta is -1/2. Okay, I can just subtract 1/2 from both sides. Well, let's go ahead and do that later. Okay, so first I'm going to say 1 is equal to sine theta plus 1/2, just adding sine theta to both sides. Now I'm subtracting 1/2 from both sides, and you get this. Okay, so what I need is on all the angles, and the values of theta, so that sine of theta is 1/2. Remember where sine is 1/2 on the unit circle? It's where the y value is 1/2. That's this point and this point. Okay, so the first answer, or first set of answer, is this. That's pi over 6 plus 2k pi. Then we have to also consider that, which is 5 pi over 6. Remember, that's 150 degrees, plus 2k pi. And you can't really combine these because they don't happen at a certain interval like this one. Okay, so the answer will consist of 2 lines, basically, pi over 6 or its equivalent angles, and then 5 pi over 6 or its equivalent angles. All right, let's go. All right, number 20 has 3 parts. All of these are to find limits, and those are not just by direct substitution. So in that sense, number 20 is probably the most important type of functions on this test number 1, because you will have many questions where you have to find limits by some kind of algebraic manipulation. All right, for number 1, if you plug in 2, you get 0 over 0. That does not mean, however, that the limit does not exist. Okay, you have to do some creative manipulation to get rid of the bad guy in the denominator, which is negative x minus 2. See, as long as you have x minus 2 in the denominator, you are not going to be able to plug in number, right? Number 2. But many times you can factor. For instance, here you can factor the top as x plus 2 and x minus 2. The denominator is x minus 2. Remember, they cancel. So now you can plug in 2. And so you plug in 2 and you get 4. Okay, that's it. That's very nice, right? Next, you have limit as x approaches, or limit at pi of sine of x over tangent. Sine of x is 0, tangent of x is 0. You have 0 over 0 if you try to plug in. But let's try to do something else. It's sine of x. What's tangent? That's sine x over cosine of x. You can, as we have seen before, the bottom of the bottom is on the top. And in fact, so let's go ahead and write this down as sine of x cosine of x divided by the sine of x. Okay, this sine of x stays in the denominator. So now this one cancels. Cosine of pi is -1. And so that is the answer to that question. So in all of these, the idea is to do some algebra process, or take some algebra steps to get rid of the bad guys that are preventing you from being able to plug in the number. So this one here too, if you plug in -2, I think you can get 0/0. Now let's worry about this plus sign later. Okay, I can first factor the top into what? X2 and X4. This is going to be plus, that's minus. On the bottom, you have X2 and X1. That's minus, and this is plus, correct? Yeah, see, so from here, you can see, actually, you're trying to plug in number 2. Yeah, actually, you can just plug in number 2, I think, in this case, right? Yeah, hold on a second. Anyway, so basically, you just, yeah, you cancel these, right? You cancel these, you plug in number 2 here, sorry, -2. That's going to be 2 over -1. So the answer is -2, okay? But I think for this one, you could have just plugged it in. Yeah, because I mean, plugging in -2 is not going to cause any problem here, right? So what happens if you plug in, I didn't think about this. Let's say try to plug in -2. And you get that on the top. On the bottom, you have minus -2, -2. And so that's going to be 4 minus 4 minus 8. On the bottom is 4 minus, oops, 2, no, what is that? It's minus x is -2. So this is going to be 4 plus 2 minus 2. And so that's -8. That's 6 minus 2. That's 4. Yeah, so that's the same thing. Okay. So here, actually, the function, this fraction, this rational function is continuous at -2, and you didn't actually have to factor or cancel. You could, it doesn't, hurt, but you could have just plugged it in to get your answer. Now, there was a plus sign here approaching from the right, but again, it's irrelevant because the function is continuous, or even if it's not continuous, if the limit exists by this kind of a manipulation, as long as you know the limit can be found, then it doesn't matter if you go from the right or the left, because if the limit exists, it has to be the same as the limit from the right, which also has to be the same as the limit from the left. Okay, so that's number 20. As you go to number 21, we will go into the next video in the series.